Hi, so this is the second part of system testing called test generation from requirements and code. So you've seen the requirements pyramid before. The users or stakeholders have some kind of needs. These needs are then represented as different features. A feature could be something like an authentication system. Perhaps we have a web shop, and that is another feature that you can buy products, and then you have an authentication system that you can log into the web shop to have your own profile and your own lists of products or shopping carts and stuff like that. And you can have many different features. Each feature is connected to some kind of need, and this need is more fluffy, something that someone needs. And we express these features as use cases. One feature could become several use cases. So for instance, if we have the authentication feature, we can have a login use case and perhaps a logout use case and perhaps a registered user also use case, something like that. The collection of use cases and also other things, it could be other kinds of requirements, functional and non-functional requirements. There could be requirements that has to do with security and stuff like that. So we collect those in our specification. Each use case can then be divided down to scenarios, and we're going to look at graphs of that. So for instance, in the login scenario, we can have a successful login, and then we can have an unsuccessful login. If you write the password wrong, you're not able to log in. So those are two different scenarios, two different ways through a use case. And then you can have test cases, and test cases are connected to a scenario in such a way that you have the scenario, the successful login, but then you add test data, and that is the input and expected output. So it's a pair of treatment or input, and then it's the output or behavior of the system. So for instance, you can log in using the admin user and the admin password, and that is a successful login using that. And then you can also have a successful login using the Daniel user and the Daniel's password. So you can have two different test cases for one scenario, and it could be a good idea to have these cases, especially if there are code that can vary. I mean, you can easily have an if statement that says if username equals admin, then log in, but then the code does not work for Daniel. So you can have different scenarios. Also, the non-functional or other kind of requirements not specified as use cases can have test cases connected to those. And you could also create test cases that are freestanding and not connected to a specific requirement. Perhaps it's not yet specified as a requirement, or it's just the tester that realizes, oh, we need to test this thing. So you create these test cases. And a test case needed something to test, so this is recap, right? So you need something to test. We call that system under test. So in this case, we have a max program. It's called max, and it takes two parameters and returns the highest one of those. And then we have the treatment, the input, and in this case we have x equals 3 and y equals 4. Then you have the expected output, so that is the 4. So that was the higher number of the two inputs. And then we run the test and we get some actual output. And in this case, we have a bug apparently in the program, so it returns 3. And then we have an observed behavior. It's when we run the program, we observe a 3. And then we compare the expected to the observed behavior, and then we realize, okay, something is wrong in the max method. Perhaps it returns the first item or something like that. So I told you about different scenarios. So this is a use case. It's called authenticate user, so it's part of the login system. And some of you would recognize this, perhaps from a previous course. but some don't. So we start up here, and this is the start of the use case, the first part of it. So when we want to authenticate, and then second here is that system asks for username, password, and if the system should save the user credentials or not for future logins. And then we have the main success scenario goes straight down here. So number 3 is that user provides username and password, and then system authenticates the user and presents that authentication succeeded is number 4. And then we have alternate scenarios. So you can go through 2 and then to 3A, which is that user wants to keep this wants the system to keep the user credential for easier login. And then you have a different name here, and from this state you can go to successful login, or you can go to 4A, which is that user could not be authenticated. And you can have loops like this. If you're not authenticated, you can try again with perhaps you miswrote your password or something like that, and you can start again. So system will ask you again. But it should also present an error message, right? So you remember that one. So for this simple case, this simple scenario, we generate a different scenario. For this simple use case, we generate different scenarios. So these were the ones that I generated for another course. So you have 1.2 is failed login. 1.1 is just to navigate to the page and make sure that you have a login form, and then 1.2 is fail login without entering any fields. You just press login, and then you fail login with only username, and then fail login with only password, and then fail login with wrong password but existing username, fail login with existing password, so some password that exists in the database but you don't have the correct username, and then finally here successful login with correct username and password. And then 1.8 is that when you've actually logged into this web program, then you're actually still logged in after reloading the page, and then still logged in after reload with resend of information. Here, if you press F5 when you're using a web app and you have posted something, then you will repost that information. And in that case, you were logged in, but you tried to log in again, and then you should have a different message. You should not be welcomed as logged in. You're already logged in, so the welcome message should disappear. And then we have another test case that if you open another browser that of the same type, you should share the session. So you should also be logged into that one. So I've collected a lot of different scenarios from one simple use case. And actually, just so that you've seen, this is a requirement specification. It says that something about the system, and then you have a supplementary specification telling you different kind of requirements that are not in the form of use cases. It's like this: the system should respond to input in an acceptable time frame, and as you hear here, the requirements are specified in not so clear. So we as testers must use our heads and think, what is an acceptable time frame? And I would say that, okay, in a web application, if in case you're logging in, you're not doing that a lot. Could be a couple of seconds, but not too many seconds. You're gonna lose customers and they're gonna be worried and start trying to log in again. So perhaps you should do a study with a couple of users to see what is an acceptable time frame. And I mean, this also depends on the kind of application. If you're doing this all the time, then you don't want to have long loading times. But if you're doing this once and then you're kept as logged in, then it doesn't really matter. You could also like look at the competitors, other systems for logging in, see how long they are, and perhaps you can gain an advantage if you're faster than those. Yeah, system should be user friendly. I mean, this requires other kinds of testing, like okay, if it's going to be user-friendly, perhaps we should try it with different types of users. Perhaps we should look up some what it means to be user-friendly. And there are probably checklists for creating user-friendly web applications and stuff like that. Provide helpful error messages. Okay, so as you hear, this is kind of fuzzy, and you need to interpret these as a tester in order to test these. So what does it mean to be helpful? Perhaps the best way of testing if something is helpful is to let other people try the system that are not accustomed to that one, and perhaps a part of the end user that are gonna do this. If it's gonna be elderly, perhaps other kinds of error messages are helpful than for young people or for tech-savvy people. Okay, the system avoids unnecessary input, and I mean this is sort of general guidelines for the system, and I think as a tester you should read these, and perhaps some of these you generate tests from, some of these are just perhaps you do exploratory testing and to make sure that these are okay. So I would say that system avoids unnecessary input is one of those that perhaps you always carry that with you, and you do some exploratory testing of the system to make sure that you don't need to input the username twice or click too many times to achieve a certain thing. Should be secure. I mean, security testing is a thing. It's sort of out of scope of this course, but could be in scope of, or it's sort of in scope in assignment 2, where you can decide what kind of testing you want to do, and you can investigate different types of testing. Should follow web standards. Oh, then I would probably run We3C's web validator. And then we have some security consideration. Oh, so it's more specifying what was. So SQL injections, JavaScript injection, password handling, session hijacking. And I mean, in order to understand these requirements fully, we need to read up on the subject. So we as a tester need to understand the problem domain that we're trying to test, and we need to put ourselves in the shoes of end users, we need to be technically experts in this field, and we need to try to understand these different things in order to test these. And this is the case in assignment 2. So you need to understand a bit of how web servers work in order to test these. And I have deliberately chosen a web server, since I mean the web and HTTP protocol and stuff like that, you should, after getting a computer science degree, have a deep understanding on how these work. So it's even if the domain knowledge of web servers is not testing per se, it's still good knowledge. So you need to spend some time with trying to learn that. There is actually a source where I think you can take a look at, and I think it's like the HTTP made really easy. So I think it's, yeah, so I think this one, if you want to try to understand HTTP protocol. So this looks a bit old, and it's probably a bit old, 2012, but it's a bit older than that. But reading through this would give you an idea on what HTTP is, the different kind of standards. These are the old standards, but start simple. And then, yeah. Okay, so and then we have the use cases, and you can see it's pretty much the same scenario. And here we have another use case, and here we have another use case, and here we have another use case. So, and from these we generate test cases. So these are the test cases. We had the first test case, navigate to page. There is a short description of the test case. It is, yeah, continuous description of the test case. Then we have the input. You should remove existing cookies and navigate to site. Doesn't really specify the actual site in this case. You need to have a link to that one. And then we have specific output. So the text not logged in should be shown, a form for login is shown, and today's date and time is shown in correct format. So this is actually the application. So do we have that? So we input, we clear the cookies, application cookies, clear that one, and then we navigate to page, and we can close that one. And so what did it say? Test case, clear existing cookies, navigate to page, text not logged in is shown. And whenever I get this, you can always do a search for stuff like not logged in. Okay, that is shown. And okay, form for login is shown. Sure, we have some kind of form for login. And today's date and time are shown, should say are shown, in correct format. Okay, and the format is up here. Day of week, the day of month in numeric, the month as text, year in 4 digits, hour, minutes, and seconds. Like this, Monday, blah, 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 the time is, okay. Monday, the blah, 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 the time is, yeah. Okay, that seems legit. And as you heard, I sort of cheated a bit there. So, and I mean, this kind of exact checking is sort of boring, especially if you're like me and you have done it a million times. Okay, actually in this test case I've included a screenshot also, so that this part down here is part of the test case. It shows a screenshot on how it should look when it's okay. Then we have test case 1.2, failed login without entering any fields. Make sure login cannot happen without entering any field. Okay, so test case 1.1 is input as this one. So we have already done that, so we don't need to do it again, but make sure that both username and password are empty. Okay, empty, fine. Press login button. Okay, something happened. Username is missing is shown. The text not logged in is shown. Yeah, that didn't change. Feedback, username is missing is shown. Yes. And a form for login is shown. Good. So, and here also we have a screenshot. And I think these screenshots are pretty good in order to like quickly get an idea on how it works. Of course, you put the test cases and the actual application or system under test next to each other. It's much easier to test. And then it just continues. You have all these manual test cases. And these manual test cases are pretty good to have, because when we're gonna get down a bit here. So when you find a bug, then you can regression test. You rerun the same test case again with the same input, and you make sure that the bug disappears. So here we have a test case which has input. So you enter the password and username the admin, and you can see that I've noted that it should be a little a. The actual correct password is admin with big A, I think, yeah, up here. So that is an existing username, so you should not be able to log in if the password is correct, but the username is not correct. So these are specific inputs, and they are specific because we don't want the tester to decide these when they check the test case, when they run the test case. We want to decide this before, so that if we have a bug, we should not get two different results depending on what the tester decided. So perhaps the tester decided to change the username to something else, and then we were not able to log in. But if you are having this exact test input, then you are able to log in, and that is a bug, right? So don't you should have specific, and also these should be specific so that we can copy these and search easy. That also makes it super easy to automate these tests afterwards. So, but it also to have these specifics also makes the test case is less valuable, but we're going to talk about that in the future. Okay, to make sure that every requirement is covered by some tests, you can have this requirement test traceability matrix. So we have the requirements on the x-axis and the test cases on the y-axis, and then you can have a measurement up here that everything is covered. And I mean, some of these should probably have many test cases for a single requirement, since a use case can probably have many scenarios. Okay, so probably you think that, oh, this is a lot of work, and yes it is, but it's less work than testing everything. So we previously expressed a term called exhaustive testing, which was to test all possible inputs. And I mean, for just this simple login system with two different inputs, username and password, you can have too many inputs, too many test cases. I mean, you can test so many failed passwords. Yeah, it's an infinite number, more or less. So we're unable to do that. It's not practically possible. It's not. So we need to think of what is effective testing. So, and this is the test selection problem. You should select a subset of tests so that we reveal all errors in the program. So that is sort of the idea, right? So we need to test smart. And to recap that the goal of testing is actually not to test everything, but to uncover errors and build confidence in the software. So for the customer, for ourselves, for many reasons, right? And this is a funny picture from Age of Conan 2011, where they had a bug that made the horse invisible. Okay, so given that we don't test everything, we need to select something. So where do we put the limit? So what is the ideal test suite? What should we look for? So we need coverage, and we already said that for all requirements, you should probably have a test case also to make sure that this test case or this use case or this requirement is in the product. We validate that it's in the product. You might also want to have coverage over the different paths through the use cases. So you have like a use case path coverage, so that I know that you have taken all the different paths. So let's take a look at this one again. So you at least all the arrows here are covered, and perhaps you also want loop coverage, so that I realize that I've actually taken the failed login and gone up here and perhaps twice or something like that. Yeah. So different coverage, and also source code coverage. You want to perhaps be able to say that during testing all source code was tested, at least run during this. And I mean, there are other types of coverage also. So the ideal test suite also not only cover things, it finds bugs if there are bugs. Yeah, simple as that. We cannot be super sure since we don't test everything, and we don't prove that we're bug-free by not running everything. The ideal test suite should also run fast. It should be automated, and it should automate the things that are boring. And I mean, you saw me just running one test and I cheated. So we want to reduce painful regression testing. So running the same kind of test over and over again, checking things is sort of boring. So we want to reduce that boredom, and we automate to do that. We also want to be able to change. I mean, requirements change when you learn more about the product and how it could be used and should be used. Then you want the requirements change. You want the test suite to be able to change with it. And in order to be able to change, it should not be too big. You don't want to have redundancy. You don't want to test the same thing twice. You don't want to unnecessary twice. You don't want to have duplication. So you've seen me refactor source code. So you don't want to have too many places to change the same thing, so to speak. So you've already heard about in source code we say don't repeat yourself, but this is also the same in writing manual test cases. Many of the manual test cases I've shown you started the same, and I've reduced the redundancy, or not the redundancy, I reduced the duplication by saying that instead of rewriting test case 1.1, you just have that as an input, so you can reduce that. So that is one. Okay, we also want it quick to develop, and we want to use these test cases during development. So we want to have, as developers, get support from our test suite. And we don't want to spend too much time writing these. We also want a minimal test suite that gives enough confidence for us to continue and dare do things. So we want it minimal because we want to be able to change. We also want it to be good enough for acceptance testing. So acceptance testing is when we have some kind of customer and perhaps they have ordered the system from us, and we want them to sign off and say that, okay, well done, you did what we said you should do. So if we create good acceptance, or if we create good test suites, then our customers, or the ones that order, can use those as acceptance testing also. Okay, but in order to test things, and we couldn't test everything, we need to reduce the work. We cannot test everything, so we need to make some kind of assumptions. So we make these assumptions to minimize work, and we want these assumptions to be as informed as possible. Perhaps you've heard assumption is the root of all fuck-ups, that proverb, and it means that when we do a mistake, it's usually a wrong assumption behind that. So in order to do these assumptions, we should know what we're trying to do, and they should be as informed as possible. So one way of reducing the amount of work could be to, okay, I've tested this module before, so and last iteration I didn't change that module, I changed another module, so I'm only testing the other module, I'm not testing the one that we tested last iteration. That could be an assumption that it has not broken. But I mean, this Friday I actually made this assumption, so I changed something on your course homepage. I just changed an assignment. I tried to make an assignment description a bit more clear. So I only changed one document, and then the automated test and continuous integration and continuous release mechanism started, and somewhere in that there is a bug which made the menu to disappear. So all assignments disappeared, and I didn't see that because I really didn't test it. So I mean, that assumption broke for me. So in this case I needed regression testing, which means that I needed to look at the course page and make sure that the menu appeared. But I didn't do that because I didn't think that would ever happen, because I didn't change the menu. Okay, so other assumptions could be to reduce the mental load. So let's think of the system as a black box, and you've seen this image before. We only look at the outside of the things. We don't look what's inside. We only look at the input and the expected output. So we derive tests from our specification or requirements. So more or less, that was what I've done with the use cases. And in this case, we have some square root function. We input a 9. We expect a 3 to come out. We don't care about the internals, more or less. So if we have the max method, and I have A, B, and C, and it should return the highest one of those, we could derive test cases without knowing anything about what's inside this code. So the specification is more or less like this: returns the largest of the 3 inputs. So probably at least 3 different test cases, where one where A is the highest, one where B is the highest, one where C is the highest. All inputs must be positive numbers, larger or equal to 0. So that could mean 3 different test cases also. So if A is -1, if B is -1, if C is -1, and it should throw exception on negative numbers. Oh yeah, so I would probably have 6 test cases to test this really thorough. But if I had access to the source code, perhaps really there is if statements and stuff in this source code, and these if statements could guide my test effort. But I mean, 6 test cases for a simple method like max is probably a lot, and you want to reduce that a bit in order to carry. So perhaps you have 2 test cases, 3 test cases for a simple method, depending on what's inside here, right? So if I had access, if I had white box or glass box testing, perhaps I would think utterly. So a black box testing technique is called, one of these, and you probably heard about it before, is equivalence partitioning. So what I did when I was specifying the test cases for max, when I said was one test case where A is highest, is that I grouped all or scenarios where A is highest into one scenario. So and equivalence partitioning means that you divide the input domain into equivalent disjoint subsets. And equivalent means that, okay, for all the different inputs in this subset of all inputs, then they work as the same. So, I mean, if A is highest and B and C are not negative, then, I mean, A should be returned. That's sort of the same. So that could be one disjoint set of equivalent. And then we have another disjoint set where B is highest and another where C is highest. So if I used equivalent partitioning, I would have 3 different test cases for that. And for instance, you could have a method here called add user. It takes the age of the user in years, I presume. And you could say that one way of dividing add user into 2 different partitions could be that, okay, we have valid input, like valid ages, so you can be 0 years old, or you can be 120, but we say that perhaps people don't get older than 120, at least not our users, so we say that 121 are not valid, invalid input. We can have negative age, you can have super large ages, that is also invalid. And I mean, this looks almost like bigger than a 32-bit integer value, I don't know, could also be. So I divide that, and for all valid input, the method add user should work as the same. So I create an equivalence partitioning. So this is a nice way of reducing the number of test cases. You select one or a couple of test cases from each equivalent partition. So, okay, the difference between equivalent partitioning and black box and white box testing is that in white box testing you don't only have access to the requirements or the outside, you also have knowledge of the inside. So in this case we have a method called getUser, and the user should return a user object from the user interface. But actually this code also does other things that are not visible from the outside. It has what we call side effects. So in fact, this method in PHP, here is the main success scenario where we go in here and you return the actual user object. But we have all these if statements, and these if statements are actually side effect. And a side effect is when you do something that this method is not really about. So it also creates a lot of messages. And we can see that we have a couple of if statements and we have a couple of a try catch. So if we have knowledge of the source code, then we can create test cases with using that. So for instance, we might want to create test cases where we go into the first if statement And then you see, since this is not else if, then you can go into the first and into the second, or just into the second, or just into the third, or into the first, second, and third. So when you think this way, then you're actually white box testing. So you think about the code and how to do that. And this sort of generates or are responsible for the different equivalence clauses. So when you have an if statement or a for loop or something like that, then you branch the equivalent clauses. So you have one equivalent clause of inputs that would put you into the first if statement, and then you have another one which puts you in first and second, but not in the third, and so on. So I mean, the more complicated the code is, the more if statement you have, the more equivalence clauses, so they just explode. So that is why we want to have code that has few if statements, because it's much easier to test, it's much less complicated. And I mean, this code here is horrific. Yeah. So and sometimes it's pretty hard to use the concept of equivalence partitioning when you have a source code. So in this case, there is Java code instead. So I try to vary my examples. In this case, we have a case where we have a method called read, and it normally returns nothing. But if the buffer, I guess this is reading from some kind of input which the user is putting it. If it contains a line break, then we I guess return everything up to that line break. So if the user presses enter, I guess that is what has been before the enter is returned, right? So the equivalent partitioning of this would probably be from this. So you input something, but in this case, read does not take anything because it's some kind of internal buffer. But going into this and returning whatever and not having a /n. So I mean, these if statements are sort of guiding your test effort, and creating different equivalent partitions. So we have another case here where you need multiple partitions. So when we had get loan with only age, we had sort of one partitioning. But if you had two different inputs, then you need multiple partitions. So we have a requirement that says that customers of age between 18 and 65, bigger than 18 and less than 65, no, less and equal to 65, gets a loan if their salary exceeds, and that means greater than, it's not equal, it's greater than, exceeds £25,000 a year. And then the method looks like this. So let's start identifying input domain first. So we have two integers. So I mean, these could be the age, and I would divide this into valid and invalid age. And then I would divide the salary as invalid and valid salary. You cannot have a negative salary, I guess. It wouldn't work if I got a negative salary. So you can divide that into different categories, and then you divide the age into, I mean, the valid age also has a higher limit that we talked about, 121 perhaps, and the salary probably don't have a higher limit, but we can divide that into less than and equals to 25k and greater than 25k. So now we've identified the input domain and partitioned each partition into different subsets, and then we combine these and we end up with something like this. So you have, I mean, lower than negative age doesn't really matter. It's the same thing as with a positive, but less than 18 age. So you don't get a loan, it returns false. A salary or negative salary doesn't really matter in this case either. So we sort of scrap that because you don't get a loan with a negative salary, and you don't get a loan if your salary is 25k or less. And as you can see, the age is on the y-axis and the salary is on the x-axis. And then you get different combinations here. So E1 is where you have you're underage and you're underpaid. And then E is when you have enough payment, but you're still underage, so you don't get a loan. Why you would need a loan if you earned 18k, 25k as a 16-year-old. One can wonder. Okay. And then we have the case where E2, where you're actually 18 or over, and you're under 65, but your salary is too low, so you don't get a loan. And then we have the sweet spot where people are the right age and do have enough salary to get a loan. And then up here we have you're too old and too rich. And here you have you're too old and too poor, and you don't get a loan. So I mean, having 6 different test cases might be a good idea. But if we include another, it's sort of white box, black box thinking here, called boundary value analysis. This is sort of based on the kind of mistakes we do. In this case, we had age and salary, and we had specific numbers that were breaking these. It's quite common that programmers make mistakes on these equivalence, greater than and equal, or less than and stuff like that. So if programmers are commonly making these mistakes, if these are rules and specific numbers, then perhaps we should do what's called boundary value analysis, which means that we had identified the actual boundaries between these partitions, and then we create test cases on these boundaries. It could mean like this, so the same image again. So if the age is 18, we make sure that 18 is for the E5 and E2 test cases, we use 18 and not 19 or 20 or something like that. In the middle, we use the edge cases here. 18 is included. But we also create a test case for E1, which we use the underage limit, so 17 there. So we have both sides of these. And this might mean that since E2 has 2 boundaries, we create one test case where age was 17, and then we have one test case for E2. No, 2 test cases for E2 where one is 18 and one is. Should 65 be included? Yes, it should be included. 65, and then you have one test case for E3, which is 66. So you have just for the age you get 17, 18, 65, 66. And then for the salary, you have a similar case where you have 25k and then you have 25,001 on the other side. Yeah. So, and then you have all the combinations. Suddenly you have a lot of test cases. Yeah. Okay, so that was sort of the topic of today, and so I'm gonna end with just some talk about this week. So this week it's examination time of assignment 1 part 2. So in the schedule there are examinations, but really you only go to your slot if you have decided on taking this examination and you have decided on a slot. I'm gonna move a couple of these slots because my schedule got changed, but I'm gonna talk to the individual students on that. So assignment 1 part 2 is an oral examination, so we're gonna have a talk, you and I, and it's individual, so even if you worked in a pair, you have an individual examination. We contact each other on the slot or before the slot in Slack, so we talk there. And please do check that your microphone and headset works, and that I want you to have a webcam also. It's not only nice, but yeah, it's quite good. I also want you to prepare by taking a look at your source code, finding a couple of good examples of TDD commits, so to speak. And let's take also look at the study questions and discuss those with other people. You can ask questions on those in Slack also. For the rest of you, and perhaps for you who have also done assignment 1 part 2, everyone should start on assignment 2 now, and you should start working on that and ask questions on it and get it to run and start testing it and spend 20 hours per person in the group testing this and reporting it. Don't forget to read the entire assignment, not only task 1 but task 2. Okay, I think that was it.